Okay, this is Algebra 2, Lesson 29. We're talking about uniform motion problems. We've talked about this before, and we've talked about it where the distances are the same. So the distance traveled have been exactly the same. So it could either look like this or this. They've traveled the same direction, or they've traveled in opposite directions, but the distance has always been equal. So we've been able to equal them together. In essence, remember, distance formula is rate times time. So we can say R1T1 is equal to R2T2 if D1 and D2 are equal. Now we're going to talk about the sum of the distances equals some number. So we're going to say that D of 1, the distance of 1 plus D of 2 is equal to some number K. And it's going to look something like this, D1, D2. That's only one example. I mean, they could also be going in opposite directions or coming towards each other. That's just one example. If you look at the bottom of page 131, you'll see the other two options. And so basically what we would say is R1T1 plus R2T2 is equal to K, some number K. So let's look at a problem. Let's look at example 29.1. Talks about Napoleon walked part of the 60 miles to the site of the battle and rode the rest of the way on a caisson. He walked at 3 miles per hour and rode at 9 miles per hour. If the total time of the trip was 8 hours, for how long did he walk? So first of all, we have to set up our problem. So the first thing is you do need to read it. And you don't have to understand the whole problem when you read. You just have to read it, soak it in, and then you break down the problem. So we kind of dissect it. So we know we're talking about D of W, which is a distance walked, and D of rode, the distance he rode. We know that he walked part of the 60 miles. So we're saying the whole thing is 60 miles. He walked part of it, and he rode the rest. We don't know. I mean, it could be he walked the majority. We don't know. We just know that there's a break somewhere. Okay. Then they told us he walked at 3 miles per hour, where miles per hour means rate. So R of W is 3 miles per hour. And said he rode, so R of R is 9 miles per hour. It said the total time of the trip was 8 hours, so the time that he walked plus the time that he rode is going to equal to 8 hours. And the question is, for how long did he walk? What was the time, his time of walking? So that's what we're trying to find. So let's put in our equation. So we've got R of W, T of W, plus R of R, T of R, equals 60, because we said the distance. He walked part of the 60. That indicates that the whole thing was 60 miles. So we have R of W, 3. Do we have T of W? We can find it by saying T of W equals 8 minus T of R. So we're going to do 8 minus T of R plus, what is R of R? 9. Do we know T of R? No, we don't know it. Equals 60. I have to use my distributive property here. It's 24 minus 3TR plus 9TR equals 60. Okay, so I'm going to go ahead and take this to the other side. Oh, I'm going to combine these two. We get 24 plus 6TR equals 60 minus, and I'm just using algebra, so if I'm going too fast, get me in class and we can talk about, at this point, you should be able to know how to do simple algebra. Divide by 6, so the time that he rode was 6 hours. But they want to know how long he walked. We want T of W. So we simply put it back in this formula, 8 minus 6, so the time that he walked was 2 hours. That's it. We don't have to find the distance. We could find the distance he walked and the distance he rode by putting these back into the formula, but they didn't ask us for that, so we are done. We don't need to go any further. So let's look at the next example. Let's look at example 29.2. It says Edward Longshank and Queen Eleanor were 54 miles apart. Edward began the journey to the meeting place at 8 a.m. at 3 miles per hour. 2 hours later, the Queen set out to meet him. If they met at 4 p.m., how fast did the Queen travel? So let's start with what we know. We know we've got the distance of Edward equals R of E, T of E. And then the distance of the Queen equals R of Q, T of Q. That's the first thing you're going to have. You're going to find the two things that you're finding the information for. We know it's Edward's and the Queen's. Then they said they were 54 miles apart. Okay, so we know the distance was 54. All right, so the distance of one plus the distance of the other equals, so we know that D of E plus D of Q equals 54 miles an hour. And we can simply do R of E, T of E plus R of Q, T of Q equals 54. So let's write down what we know. We said he began his journey at 8 a.m. So 8 a.m. is Edward at 3 miles an hour. So his rate is 3 miles per hour. 2 hours later, the Queen set off to meet him. So that was 2 hours later. So she left at 10 a.m. So this is the Queen, and she's coming this way. And then it said at 4 p.m. they meet. So the time that Edward took to meet from 8 to 4 was 8 hours. So T of E is 8 hours. And the T of Q is 6 hours. It's from 10 a.m. to 4 p.m. That's why you got to set these up so you can see what you're doing. All right, it says how fast did the Queen travel? So we want to know the Queen's rate. So we want to know R of Q. That's what we're finding. So let's plug in what we know. We know R of E. Do we know T of E? Yes, 8 hours. R of Q? No. Do we know T of Q? Yes, 6. It's 54. So I'm going to minus 24, and I'm just kind of combining steps here. Multiply those and got positive 24. To get rid of that, I did the opposite, which is negative 24. So R of Q, 6 R of Q equals 30. Divided by 6, the rate of the Queen is 5 miles per hour. And I'm done because that's all they asked me for. I could find the other parts, but I don't need to. So the code for this lesson is the number 75 on the top of lesson 27. The code is 75 on the top of lesson 27. Do your practice problem. There's only one. I want you to look at example 29.3, and then we'll go over this in class. Okay?